Okay, today I'm going to be going through the IB Biology IA. Just want to note first of all that I did standard level biology, so I'm pretty sure that it differs from the HR1 in that HR1 is more complex and has a bit more to it. But this should at least give you a good idea if you're just getting started with your IA, just to give some general advice that hopefully some of it will be useful to you whether you're in high level or not. So yeah, I'm just gonna run through these different points. So I'm gonna go through like the structuring and the backbone of your IA, then I'm gonna go through the process that it usually entails, and then general advice will just be general tips that I found useful. Also, I just want to mention as well that my IA, well, all biology IAs and science IAs are very different to each other. So it's really dependent on like the topics that you're choosing, the variables that you have, the methodology, or the like, what's it called? The process that you're going to use to like collect your data and everything differs very widely across IAs. So this is just my experience with it, and it might not be, it's definitely not like the only way to do it or the best way to do it, but it's just an idea. Okay, so first we'll go into the general structure of the IA. So this is the structure that I used. Like, this is just like the rough way that I kind of separated out my IA and like did each section of it. So again, this is not the best way to do it, but just an idea of what things you might want to include. And of course refer to the criteria that is given, because that can change as well across years. Okay, so usually the first part you'll have an abstract or your annual introduction. So just make sure this is really clear and concise and contains your background knowledge on the subject that you're using as the basis for your experiment or your practical, whatever. And just don't make it too confusing or too wordy, or don't include information that's really unnecessary. So this is my sort of introduction. So my investigation was an investigation into the impact of increasing hydraulic acid concentration on the mass of bivalve mollusk shells. So this is my abstract. It's just very simple, explaining the focus of the investigation, exploring a global phenomenon by testing the impact of acidity on calcifying marine organism shells, more specifically bivalve mollusk shells. And then I'm going to explain the aim of the investigation, mentioning my different variables, and then I'm saying that the data will be statistically tested using standard deviation, standard error bars, and Pearson's correlation coefficient. And then I'm saying it's going to conclude with this hypothesis that should be accepted. Nevertheless, so just a very simple overview that does kind of say what your findings are, but obviously not in a very detailed way. So just a very good broad overview of your paper, basically. So actually you should usually, I think, write this at the end of your paper. You can obviously draft it at the beginning if you want, just like a little bit, but yeah. Oh yeah, and then introduction here. So this is where you're doing your intro and background knowledge. So I'm just basically explaining the phenomenon that I'm investigating, which is ocean acidification, talking about how it's like a world issue a little bit, and then relating it to my IB geography lessons. That's how I became interested in this topic. And then I wanted to explore it in a more sort of like biological way. Then I mentioned like this documentary that I watched, which I don't know if that was really necessary, but I think it does kind of give that personal like touch to the IA, so it's not like, I suppose, boring. Like, I'm not just saying, oh, I want to do this because it's interesting, but I'm actually kind of giving like a solid enough reasoning behind it. Yeah, so then I'm saying, hence I decided to explore the impacts on all other organisms, because that one was mainly on coral, so I want to see what happens to other organisms. So I'm saying, using these organisms, these are composed of calcium carbonate. They play a crucial role in marine ecosystems. Then I'm going to my background knowledge. So I'm giving, things that you learn in your lesson. So these are like things that you might come across in like a basic biology lesson. So that's good to include just to show like you're using a basis of simple biology. Then I'm giving, the process of induced carbon dioxide induced acidification. That's my background knowledge. So from this, increased acidity should lead to an increase in the rate of decline in mass of calcium carbonate marine shell organisms. So basically, you want to simplify all of this background knowledge into a hypothesis or a research question that is supported by the background knowledge and is also unique and sufficient for like an investigation. So it's a very specific question, detailed, has the different measurements and everything. So yeah. Okay, and then you want to go into your investigation. So here you want to outline your hypothesis and your null hypothesis, which is very important, different variables you're including, and possibly a preliminary experiment if you've done one. So I'll go and show you what I did for that. So here's my investigation. Here we see my two hypotheses. So my hypothesis and my null hypothesis. Then I'm going to my different variables, very detailed. So the thing you need to keep into consideration is that the science A needs to be detailed, needs to be, like very, very meticulous. I don't know if that's the right word to use, but just you want to have all those details in there and don't miss anything, basically. So I'm giving all the molar concentrations, like this way I calculated the dependent variable, time period, the time range, my controlled variables, and then my preliminary experiment, just like something I did beforehand just to see how it would work. And then I found out how much time would be most suited for the organisms in the experiment. So it turned out to be 24 hours, because if I left it for longer, then the organisms would completely dissolve, so it would be difficult to substantially compare the values. So I did 24 hours instead. Okay, and then you go on to your procedure. So that includes things like your apparatus that you've used, justifications for using these, safety points, ethical points of your investigation if that is something to consider, your methodology and justification for this methodology. So here we have the procedure. Apparatus in the table was the easiest way to do it for me. So I did all the apparatus, then I did justifications for each of them, like to stir the solution, to measure the pH, to dilute the hydrochloric acid, to use serial dilutions, and things like that. And then safety and ethics, just a few points, ensure organisms that are sampled are deceased. So I wasn't just killing organisms, but I was just using ones that had already been killed, just so just to make it as ethical as possible. Don't ingest anything, wear a lab coat with the hydrochloric acid, dispose of acidic solutions properly. And then food waste, like trying to reduce food waste by making sure the organisms were used for cooking, not just kind of used and then thrown away or something. Then my methodology is here, so very clear, and make it so that someone could literally follow these instructions. So if you read it, it's like gather, prepare, repeat before each trial, pour, so kind of very, I forgot what the type of wording is, but it's like, I don't know what it's called. What is it called? Okay, I'm pretty sure it's called imperative language. So imperative language. Then I have a diagram to show what I'm doing. So these are my little shell diagrams, and then the acid at different concentrations, just to give a little extra detail, justifying why I did this. So I'm saying what's it called? Okay, so I'm just explaining my scale and compared to the real world, and like why my method might be more precise. So yeah, just giving a justification basically. Then you have your data presentation and analysis part. So raw data tables, process data tables, and calculations, which I'll quickly run through. So here's my raw data, initial and final mass, that's what I was recording. So I've got all of those shown here with a little note here, because there's a thing where there's a certain buildup on muscles which could have impacted the final mass, so I scraped it off beforehand. Okay, then I'm doing process data, so percentage change, standard deviation, standard error, showing how I calculated that. Okay, and then here I've sort of restated my hypotheses, and then shown my manipulated data in these lovely graphs with explanations below them. Make these very detailed, and be scientific, if that makes sense. Like, make it very precise and clear. Then finally, then you have your statistical analysis, which is where you present, analyze, explain, and critique all of the data you've collected in relation to your hypotheses or your research question as well. So I'm saying to establish a statistical difference and test the inconsistency observed in the above groups. Test of Pearson's correlation coefficient was carried out. So I'm doing another sort of statistical test using this theory, why I've decided to use this test, how I've done it using this function on Google Sheets, what the meaning of this is, showing a graph of this information, analyzing that, explaining that, yeah. Then finally you have your conclusion evaluation, which is just, the basic conclusions, strengths, weaknesses, and extensions of your IA. I am sort of skipping over this part just because that goes into theory, which everyone's IA is probably not going to relate to, or it'll be very different from mine, so I'm not going to go in explaining too much about this. But anyways, so I've done my conclusion. So the initial research question can be answered because when HCl concentration increases, percentage mass of clams increases, and then I'm talking about the difference across the different organisms. Can I reject the null hypothesis? Yes. This is supported by my values of the calculations that I showed earlier, and that would match the finding of existing studies. This threatens that ocean acidification threatens bivalves by diminishing the availability of carbonate minerals. So yes, going into a bit of theory. Then I decided to notice a little thing about another study that relates, so saying how this could change over time. These institutions says this and this, different marine organisms are variably susceptible to ocean acidification, so this is why this is important, and I could potentially extend this investigation. Then I'm doing all my strengths, the weaknesses of my investigation, extensions, which is basically a potential extension could be testing different hydrochloric acid concentrations on a larger variety of marine organisms like crabs, snails, because that would be more robust, or to see the impact of increasing temperatures, because that's also another factor that relates to changing pH and the idea that global warming has exacerbated global ocean acidification. I don't know why I can't talk today. Anyways, yeah, so extensions, then finally bibliography, of course. So I'm saying that these extensions would make it more extensive to analyze the global issue. So that's basically just a nice overview of everything. So yes, I hope that gave you a good idea. Here's a little overview of your general process, and really important here, just want to mention, is to speak to your teachers and peers, discuss your ideas for approval, go to different teachers if necessary, because some teachers specialize in different topics. My general advice is to be realistic, plan, make it interesting, well thought out. You don't want to be struggling at the last minute and having to replan everything. Communicate again. As I said, be practical. These IAs require practicality, efficiency, and detail. So just try to make it as easy for yourself as possible, and good luck. Thank you.